So we've looked at some different methods of factoring things, right? And so now we're going to look at having them all in our head, right? And getting to what's called factoring completely, okay? Remember, the one thing I've always told you to do is always look for a what first whenever you go to factor something. Yeah, so make sure that you always look for a GCF first. All right, so we know how to factor out GCFs. We know how to factor a trinomial into two binomials, right? You get halfway done with the x and the x, yeah? Yeah. And when it's a little more complicated, we know how to do that A times C method, right? Remember how to factor a difference of two squares? A squared minus B squared. No. It's sort of a butchered version of the Pythagorean theorem, but is it A plus B times what? A minus C? Remember? Okay. So keep that in mind. So let's take a look at this exercise 1. 4x squared plus 20x plus 24. They want us to factor it. Okay? We can take it step by step, right? What's the GCF? You agree it's 4, right? So what's that leave us inside there? Squared 5x 6. Okay. And now that thing inside looks like the simpler version, right, of a trinomial, right? And so, like, separately over here in part B, they want us to completely factor it, right? The 4 is going to stay there. Get halfway done. I need numbers at what? Also add to 5. Okay. Both positive? Yeah, so that's completely factored. So you see, like, if you hadn't been looking for a GCF at first, you probably said, I got to use the AC method, right? But if you sometimes pull out a GCF, will save you from that. All right? Not always. All right, let's move down here. So they basically just want us to completely factor each one of these. Okay? So let's take part A. What do we look for first? And, okay, so we can factor a 5 out of this. What's that leave us? Minus 2. Okay. So that thing inside, we're going to have to use what method? To factor it. Okay, thank you. The A times C method. Anybody ever heard of that? We talked about it, didn't we? Yeah. Yeah. I probably just brushed on it a little bit, but anyway. All right, what do we do first? Never mind 5 right now. AC method of factoring. 2 times negative 2 is what? Okay. I need numbers that multiply to negative 4 and add to 3. What are those numbers? Negative 4 times 1. That's negative 4. Well, hold on. You sure it's negative 4 and 1? Huh? Yeah, because these will end up adding to what? Negative 3. And we need positive 3, right? So it should be what? And so then 4 minus 1 equals 3, right? We're good? So this equals 5 times what? What are we going to do? We're going to split that middle term up into what? 2x squared plus 4x minus 1x minus 2. Okay? What's the GCF in that first group? Notice the 5 stays there all the way, right? So we can factor a 2x out of the first group. What's that leave us? X 2. Second group. What? 1 maybe. Look at the signs though. Let's factor out a -1 from that second group. Does that leave us then? +2. So now we got 5 times what? X plus 2 times. There you go, factored completely. Okay? Put kind of like all our factoring tools together. Okay? All right, you guys try part B. What's the first thing you should look for? Okay. Just a quick thought. I'm looking for a GCF to factor out. What do you think I'm hoping it would be? In this case here, what do you think I'm hoping the GCF would be? Yeah, right? Because then you have a 1. Yeah, and then it's a simple thing. So what is the GCF there? Is it 3x? So it's 3x. When we factor it out, what's that leave us? -7x plus 12. Now it's not that hard, is it? What do we do here? Anybody? What do we do? This is a simpler one. Just get halfway done, right? She says -4, -3. What do you guys think? Is she right? Well, what's -4 times -3? And what's -4 minus 3? And there you go. Done. All right, move on to C. So guys, in this case, when I'm looking first for a GCF, what do I kind of hope it'll be here? In this case, I'm hoping it's a 7, so you might try that, right? Not always going to work that way, but what do you think you say it is there, Emily?
7 and then x plus 5 and x minus 2.
Did anybody get that?
Yeah.
She's always did like the final answer.
Oh.
Right.
Yeah, it was 7x squared.
So when you factor out the 7, leaves you with x squared what?
Plus 3x.
Is that what you had, Hannah? Okay. Is this a simpler trinomial to factor, guys?
Yeah.
Uh-huh. So it's 7, and what do we do? Yeah, get halfway done with it, right? 5 times -2 is -10. 5 minus 2 is 3. So there you go. All right, last one there, D. What are you hoping the GCF will be? I'm kind of hoping it's 6. Right, that's what I was getting at. It'd be nice if you could factor 6 out of everything. I think hopefully you can see you won't be able to. So either way, you can handle it, right? What is the GCF? What's that leave us with?
3x squared minus 2.
Yeah, okay. So what are we going to have to do to factor this guy? Oh, the A times C method. Have we covered that yet?
Yeah.
All right, wasn't sure. Did I give you the steps for that? I might have forgotten to give you the steps for the
Yeah,
A
you
and C
did.
method. Did I? Are you sure?
Yeah.
Okay. I just want to make sure. Sometimes I forget to teach stuff, you know? Tammy, can you tell me the two numbers we're going to split our middle term up into? Yeah, we're here, yeah. It's our middle term. You got that, right? So, Cammy, what are we going to split that middle term up into? That's a negative 1x, right? Not too many numbers that multiply to 6. Okay, 2 and 3.
-3.
All right, let's see. Negative 3 times 2 is what? Okay, that's good. What's negative 3 plus 2? Oh, we're good then. Right? So it's going to be 2 times what? What? 3x squared minus 3x plus 2x minus 2. Huh? Serenity, what's the GCF in the first group? Okay, so we have 2 with a, well, just 3. So you got the number. You also have to look, see if there's an x you can take out as well. 3x. What's that leave us, Serenity? Divide, what's 3x squared divided by 3x? X, that divided by 3x. Minus 3x divided by 3x is 1. All right. Second group, Hannah, GCF. Well, factoring is, yeah, dividing out a number, right? So you said the greatest factor is 2? It's 2. And now you divide to see what's left inside. What's left? 2x divided by 2 is, the 2's cancel. X negative 1, right? Negative 2 divided by 2 is negative 1. All right. So we're almost there, yeah? So we have, what now? X minus 1. Yeah, there you go. All right. Okay. Now on the other side, we're going to have to remember how to factor a difference of 2 squares, right? Maybe you have your list of perfect squares somewhere close by if you don't have them, kind of automatically in your head, right? So let's look here. So we want to, okay, so now we're looking at difference of 2 squares, yeah? Okay, a squared minus b squared equals 8 plus b times a minus b, right? For that. A plus b times a minus b, right? But of course, we want to look for what first, always? Is there 1 here? What is it? 2. Does that leave us? X? X squared minus 9. Is x squared a perfect square? Is 9 a perfect square? What is 9 a perfect square of? Okay, so it's going to be what? Look up here. X plus 3. I got to squeeze in and then. What did you mean to say? Times. What? Minus 3. A plus b times a minus b. Yeah? Okay. Let's try b. Is there a GCF? 5x, yeah? Go on, everybody. X squared minus 4. Is x squared and 4, are they perfect squares? 4 is a perfect square. What's the square root of 4? So this becomes 5x times what? Plus 2 times? Yeah. Okay. Move on to C. See if you guys can get that one. Elizabeth, is there GCF in C? What is it?
Oh, okay. That was one.
Greatest common factor.
Oh.
I can't get a 2 out of a 3. Start with the numbers. What number could I divide 12 and 3 by? What? It would be 3? Okay. So it's 3 times what? What now? 3 times 4x squared minus 1. Is this a difference of 2 squares? Is 4x squared a perfect square? What's the square root of 4x squared? 2x. Is 1 a perfect square? What's the square root of 1? So how does this factor? What? 2x plus 1 times minus 1. A plus b times a minus b. Right? Okay. All right, one more here. Now the GCF. Mason, what's the GCF there in D? Can't get a 12 out of 60 or 54. No, not 8. Can't get 8 out of both of those. Huh?
6.
Yeah, 9 doesn't go into 24, right? So 6, yeah? All right, what's that leave us? 9x squared. Is that a perfect square? What's the square root of 9x squared? 3x. Minus, is that a perfect square?
Yeah.
What's the square root of 4?
2.
So how's this factor? 6 times what? Plus 2 times a plus b times a minus b. Yeah? Okay. So factoring completely, right? You're always looking for a GCF first, if there is one. Okay? And then after that, you're always looking for something else that can be factored after that, right? So the thing is, right, after we factored out the 3, you got to be able to recognize that that can be factored again with another method, right? Kind of like we did on the front page. All right, what do we got going on here? Let's just look at exercise 4. Yeah, I don't know. I think some of this is kind of silly. Consider 2x squared plus 11x plus 12. Does this have a GCF other than 1?
No.
It does not. Okay. Duh. All right, whatever. B. Oh, good grief. No. Factor the trinomial by, okay, A times C method. That's what we're going to do here, right? So we're going to just write down our 2x squared plus 11x plus 12. Start out finding out what A times C is. What numbers multiply to 24 and also add to 11? Is that right?
No.
6 and 4 adds to 10. Any other numbers that multiply to 24? 12 and 2 can't get us to 11.
6 and 4.
Just set that as a 10.
Negative 8 and 3.
8 and 3, okay. All right. 8 times 3 is 24. What's 8 plus 3? Okay. So this is going to be 2x squared. Whoops. Make it neat. Plus 8x plus 3x plus 12. Right. Factor out of this first group of 2x. That's 2x squared, by the way. Yep. X plus 4. Second group. Factor out of 3. Good. Same. So, it's what? Okay? And we're going to skip exercise 5. Okay? We are going to go back real quick to read these questions on 7.2. Whatever page that is, numbers 1 and 4. Page 19. We need to do 1, we need to do 4. Okay. Well, let's look at this. Okay. So it looks like the second step in the AC method, doesn't it?
Yeah.
Well, not really. Oh, I know what it is. This should be, that's a typo. That should be negative 4x to the third. There we go. Okay. All right. Well, let's try factoring it by grouping. And see, so which one is not equivalent, right? So take that group and that group. Let's just see what happens here, right? So what would be the GCF in the first group? Hmm? So I can factor out an x squared, which leaves us with what? Negative 4x plus 1. And then in the next group, I can factor out a 2, right? Well, what does it look like they did? Let's factor out a negative 2 like they did. What's left? So that'll leave us with 3x minus 4. So that one's good, yeah? What does it look like they did here? This looks like the first term, right? This looks like they did what? So they just kept the negative 4x cubed, right? And then factored this like it's a simple version, isn't it? So get halfway done. So what numbers go there and there? They got to multiply to 8 and add to negative 3. Negative 2 and negative 4. Oh, that's that choice 3, yeah. Okay. What about choice 2? What does it look like they did? What did they not touch in choice 2? Right? So it looks like they just try to find a GCF or anything, just a common factor in that one, right? So what would be the common factor? And again, that's a 3. If they factor out an x, what's left? Minus 6 plus 8, isn't it? Oh. So what's the matter? If we did that, it should be, so that's the one that's not, right? Okay. And again, another way you could have done that is taken each one of these and distributed through and combined like terms and found the one that matched that, right? Save that silliness for the actual Regents exam with a multiple choice. It was only graded electronically. They only look at the work. Okay? And then I do want to look at number 4. Another one, which one is not equivalent? Let's start by, let's just start by writing this. So 2x squared plus 10x plus 12. One thing definitely we could do is factor out a 2, yeah?
Yeah.
What does that leave us?
Is
X squared plus
5x
5x plus 6. All right, that's not one of our choices, right?
and 2.
But it looks like we could take this thing in parentheses and do what? See if it looks like that one, right? Get halfway done. What should go there and there? Multiply to 6, add to 5.
Plus 3.
Okay, so that one's fine. Oh, gosh. Well, let me ask you this. Look at number 1. Or look at, I should say, look at number 2. So this is one of the choices, right? But look at choice 2.
6 plus 2 is not 10.
Right. 6 times 2 and it is 12. Where do you think number 2 came from based on this answer here? Like, look at this, what we just got to, and then look at number 2. What do you think they did? Distributed what? Into what? Into the x plus 3, right? So they did this. Right? So there's one of our choices, yeah? So that one's good. But taking this one again, look at, say, I don't know, choice 1. Huh? What did they do to get choice 1? Distributed the 2 through which one of these? X plus 2, right? So that would be 2 times, or not times, yeah, whoops, equals 2x plus 4, and left this one alone, right? There's our choice 1, yeah? So it must be choice 3. Got it? All right.